whole time with caveats, just listing caveats about this talk, because basically it's vaporware. None of it exists. I'm proposing that this is something that we should do, but I don't want to do it by myself. And there's no code in this talk. Hopefully that'll be good for an end of the day talk. And I'm necessarily going to be kind of superficial in how I go into these things. I'd be happy to discuss this more tomorrow in detail, but think of this as something of, here's how things are now. I think we have some issues, and I think they're worth doing something different. I'll really focus on, I think, the issues that I see and where we should go. And it's really meant as motivation. If you need more of a motivation, say, it didn't seem such a big deal to me, especially since we have an existing system, and interoperating with that existing system is kind of going to be a lot of work. So I want to start just with manual dependency management. This is like super, super basic. I hope nobody does this, but you want to use some new dependency. You're writing your Scala code, you just learned Scala or something, and you're running Scala C, and now you want to use actors. So you go to the Akka website, you download the jar, copy it to your project, and well, now you try to run. Well, it has dependencies, so you forgot to look up those dependencies, download those, copy those to the project, and then keep on doing that. So nobody does this because it's high maintenance, right? If you want to go change one of those dependencies later, you want to upgrade to Akka 2.1, and well, now you got to go check its dependencies again and go download those dependencies, see if any of those changed. The other thing is collaboration. If somebody else wants to work on your project, they have to do the same stuff that you just did. If somebody wants to use your project, you're making a library that's useful, and now somebody has to go download the Akka jars, download those dependencies. So nobody does this. But of course, they solve it in different ways. Scala has inherited Java's dependency management for better or for worse, and that's Ivy and Maven. Maven is the clear winner in terms of the repository format, the metadata format, and I would say adoption. But really, the key to it in general is machine-readable dependency information. So that's both the product definitions, so like the files you actually generate for your project, as well as the dependencies that your project needs to run, compile, or whatever. And this is key because now it makes it automated. You can process all those dependencies transitively. You aren't excluded from verifying those dependencies, right? You can say, well, I don't want any of these things to change, or like I don't want them to update. Or to show me the ones that have changed since last time. But it will resolve conflicts, we'll get to that more. It is now abstracting, actually fetching those dependencies. Ideally, these are declarative dependencies. You just say, I depend on project A version 1. You don't say how to fetch it. So necessarily, a dependency manager is going to abstract over actually fetching that, and that requires caching, and if you've used dependency management in Scala through SBT, you know that's a problem. Finally, you want to let other people use your stuff, so you publish it. So this is just really basic. You have a project, let's call it demo 1.0. You use another project A, another project B, another project D, and somewhere these have pulled in 2 different versions of some project C. You have C 3.0 and C 4.0. And well, what do you do now? Because you don't want both of those on your class path. One will shadow the other. If anybody says OSGI, we're not talking about that here. There's a couple different ways you can handle this. Maven's default is nearest. So you have your root here, demo 1.0. C 3.0 is the closest to that root, so let's go with that. Ivy has the default of latest. So let's take some information from these versions. 3.0 is older than 4.0 if you ascribe some meaning to it. So let's go with 4.0 because that's newer. Ivy's pluggable, so there's another one called strict. Well, I don't know what to do with this. I don't know whether they're compatible, so you tell me. And so strict is kind of like manual. I think personally that that's really the only one that you can do in an automated system. You just don't have the metadata to know whether 3.0 can be substituted for 4.0 or not. But that's not what the defaults are, so that's not what SBT does, that's not what Maven does. You can, of course, get warnings in both of those systems in any case. But I think the key takeaway here is that you're only as good as the metadata. If your metadata relies on like semantic versioning, which I don't think is common enough to do that, and I don't think it actually solves the problem, but I won't get into that. So you just don't have the metadata to make a good decision here. So I want to next talk about caching. This is kind of simplified. It's very simplified, and it just shows what I call the on-demand model of getting metadata. So you say, I depend on project A 1.0. Well, your dependency manager says, okay, that's nice. I don't know anything about project A 1.0. I need to get some metadata for it. So then it will go, because this is going to involve getting it from some remote server, we don't really want to do that like all the time. So we want to cache it, and we say, is it in the cache? Yes. Okay, well, is it the latest? Is it up to date? Is something changed on the remote server? And this is kind of a problem with the on-demand model because you're doing this per module. And you don't want to contact the remote repository, but you have to in order to know whether it's up to date. It's not fundamental in this model, because here's how you determine that path. You say, I have some module org.example is the group, A is the name, 1.0 is the version, let's turn that into a path. Well, that tells me nothing about the content at the end, other than I know I'm going to get some metadata. So other than that, I have no idea whether what I have locally is the same as what I have remotely. So I have to do this remote access. So if it's not up to date or it's not in the cache or whatever, then I have to actually try and get it from a repository. And so I'll check a repository. If it exists, then I'll download it and cache it, and then carry on, process the next set of dependencies. If it's not in that repository, check the next one, and so forth. And so these remote accesses are kind of what can make it slow. You can mitigate this a little bit with like asynchronous downloads and such, but it's still a problem. And then if it doesn't exist, Maven 3 will actually cache this failure, and you can kind of see where that might go wrong, because if it caches failure, well, what if somebody makes it exist later? Well, how do I know that it exists later? This is a problem with the on-demand access model. So this leads into some more motivations for doing something different. I think the on-demand access model for metadata is perhaps not the right way to base your dependency management system, because your remote path can have many possible files at the end of it. So for example, like a snapshot that can be updated. There's different things you could have at the end, and you have to contact the remote repository to see whether it's up to date. Then we'll move into, I'll discuss a couple of different areas, and one of those is metadata. The POM format is kind of deficient in being able to describe, maybe not common, but fairly common needs for dependency management, and I don't think it's going anywhere. I don't think it's going to evolve or anything like that. Ivy is a little more powerful, but it's not the standard. So I think we should consider whether we should do something about that. And so I'll talk about some motivations, some use cases for that, and then very vague proposals. It's kind of like wave the magic wand and our problems are solved, but it's something to consider. The other thing is just with workflow. This is probably the most boring thing ever, but this is the kind of thing that you deal with daily. If I'm running a continuous integration server, is my cache thread safe? If it's Maven, it's not. If it's SBT, it is, but only because there's a gigantic global lock on the Ivy cache. So I'll talk about all of these things. The big motivation that I think you're probably familiar with, at least to some extent, if you've used libraries from Scala, even if you're using them from Maven or some other tool. The problem is that it's kind of a problem, but Scala 2.9 is binary compatible with 2.10. It's a problem when you're trying to use a library that was only built for 2.9 with 2.10, because that won't work. It will give you a runtime error because they aren't compatible. It's not a problem because it allows Scala to evolve, and we don't really want it to stagnate. So it would be nice if we could kind of have both. They are mostly source compatible, and so this led to people wanting to build their library against 2.9 and 2.10. And it's a little extra work when you're publishing, and maybe it's annoying you can't use some new feature. But it generally isn't a terrible idea. So we want to, in order to do that though, when you publish for 2.9, you need your dependencies available for 2.9. And same thing when you publish for 2.10. In order to compile, you need your dependencies for 2.10. So what that really is separate universes. Here's the dependencies for Scala 2.9, here's the dependencies for Scala 2.10. The best solution that I could come up with, and that I don't think anyone else has come up with a better solution that encodes to Maven metadata. So this is both a Maven metadata problem and a Maven repository problem. is to append the Scala binary version to the module name. So if I have like com.typesafe.akka, akka name will be akka_210. So this isn't a great solution, but it's fairly simple. So even if it has some problems, at least it's simple and we can understand it. But it's fragile because when they do these conflict resolutions, it only does it between names that are the same. So it's only going to do it between A and A, not A_2.9 and A_2.10. So it's outside of conflict resolution. So now we've kind of, we're trying to encode something into a system that doesn't support it, and we will pay for it. It also does not scale to any other axes, other things you might want to cross-version. SBT plugins, 0.12, 0.13. I also want to break compatibility occasionally. It helps move forward without too much effort maintaining compatibility. Same with Play 2.0, 2.1. You might want to write Play plugins. And then it's not able to handle the difference between like forward and backward compatibility. So one option is Ivy has these things called extra attributes. And I think they work pretty well for this. You would say, this is my library for Scala binary version 2.10. And this participates in dependency resolution. So it's kind of natively encoded. The problem is that nobody uses Ivy metadata. It's not published to Maven repositories. So you could say, well, let's just use Ivy metadata. I think this is a little hard to push because Ivy's a mature project. It's not really going to be developed. What we really want is something that's going to evolve with our needs. The other benefit is it's structured information. And I didn't emphasize this enough at the beginning, but really what we want is automation. To the extent that we can code things that are machine readable, we can automate. Another example, it's kind of similar, but it's actually different, and that's richer resolution. So there was a problem that came up that Akka distributes standard jars. Akka core, Akka actors, I forget all of them, but then they also have instrumented jars. So like, I think with aspects, and this is used for the Typesafe console. So if you want to debug your application, you just depend on this special version of the jars instead. And they're binary compatible, everything like that. They're just drop-in, but you can't have both on the class path. You don't want the uninstrumented ones shadowing the instrumented ones. But there's no real way to do this in Maven. There's no way to say, this conflicts with this, or this provides this. And so I forget the exact solution we came up with, but I think it was basically, I think it was either like hope for the best or write like an SBT plugin or something. But this is completely excessive and unnecessary. It was SBT plugin, Maven plugin, and every other build tool that people use. The other one is renaming something. There's limited support in the POM format for something called relocation. This is rather inadequate. It's not as good of a user experience. I'm happy to go into any of these in detail, but again, I don't want to spend the whole time on it. You always want to fix the current problems, the problems you foresee for the near future, and you also want to say, well, hey, maybe there's some cooler things we could do, because you don't want to, there's a lot of obstacles to doing this. It's kind of a high barrier. You have to really prove that it's worth doing this. And one of those things is, well, why can't we just add some extra metadata? We should have extra metadata associated with the class. With the metadata. There should be extra information with the metadata. And one of those things could be the main classes associated with the module. Then you could just tell your dependency manager, run this main class. Well, the dependency manager has the list of all the metadata. It knows, it can say, I know what metadata that is. I know what module that is. Let's go fetch the module and just run the class for you. Not thinking about this necessarily for production people who have this big build and so forth, but it's a nice way to get people up and running quickly with examples, other things like that. If you don't like this example, come up with a better one. The last motivation that I'll talk about is management and distribution. This is kind of what you deal with if you're not configuring the build or configuring your dependencies and taking use of this information. You're working with it. You're running compile. Compile then needs a class path. How's that class path coming about? It's coming about from the dependency manager, which is going to resolve your dependencies and put them on the class path. So, and then at some point you want to release it, right? If you don't ever publish your stuff, it's useless to other people. So, as a library, of course you have an application that doesn't matter, but in my opinion, the barrier to publishing is too high. If people are spending time trying to complete the 18 steps to publish to Maven Central, that's something they could be doing. They could be writing more innovative things for Scala or working on stuff like that. Cache access concurrent processes, like I said, for a continuous integration server, that's a problem. You really don't want to be limited to that. The next two are related: integration with native package managers. Well, that's kind of a thing that you don't typically care about for the libraries you're developing. You know, usually we don't mind that they're managed by SBT, Maven, Ivy, whatever. But it's still important. You might get SBT from your package manager. Nice to type pacman SBT or whatever package manager you use. Same with offline installations, kind of similar. The Maven repository way of doing things and the on-demand metadata model doesn't really work so well with offline installation. We'd really like to be able to, for example, Play likes to provide a fairly decent out-of-the-box experience, give you one download. Once it's downloaded, you don't have to download anything again. Of course, we also provide a stack, and we like to do that there too, at Typesafe. So, and repository management mirroring. If you've had any issues with the Typesafe repository recently, this is kind of related to this. Mirroring a Maven repository is very expensive and rather tricky to do. If you remember the Scala tools shutdown, this is kind of wrap that into this point. So, I guess done complaining, here's what we should do about it. What do you think? Split the metadata and the artifact repositories. Make the metadata repository stored in Git or any other distributed version control. Update and batch instead of on demand. Don't pull down the individual metadata files one by one. So don't make your caching decisions per file. Pull them down all at once, you're done. The user tells you when to update. Just do it once, efficiently and incrementally. For the artifact repository, keep that an on-demand file repository, but make the path the hash of the content. And the metadata format, I've kind of hinted at some things that would be nice to have, make it richer and evolving, and of course the tricky part is actually implementing the dependency manager that supports that, but that's implementation detail. For the metadata repository, so store it in Git. There are quite a few advantages to that. See, what do I have to say about that? Yeah, okay, I'll talk about that later. But you retrieve it locally, so you get all of the metadata all at once. This makes it possible to implement that, that run main class feature that I showed. You have it all available. You can implement a search. I've seen quite a few attempts to search for a dependency. I just want to find an HTTP library. Why do I have to go contact a remote server, or why do I have to like scan Maven Central in order to find all the metadata? There's a barrier to this. If you want to write a tool, now you have to figure out how to index all of Maven Central. So you have mavenrepository.com, but I mean, how many? You just don't see a lot of innovation in this space, and I think part of the reason is that it's not easy to get access to all the metadata. I think there's some things to consider. Instead of a centralized repository, you think SVN, right? Every action had to go to, maybe not every action, but you had centralized server for your version control. Git came along and people were like, well, why do I need that? Then you start using Git and you're like, oh, okay, what's SVN? I think the same thing here. So for the new one, I think, you know, before you had this on-demand access, I think, well, it's not even like it's a new idea, right? Homebrew does this. And then Linux distributions do the batch update, where you pull all the metadata all at once. Big questions to answer: does this scale? Maven Central's large. What is it like to download all the metadata? Can Git do it efficiently enough? Or do we just split the repositories up so you only download what you need? So can we solve that open question? What does it buy you? I think I already covered a couple of these things. Efficient incremental updates. How many times a day do you delete your Ivy cache? I hope it's decreased if you use 0.12. If it's not, please reproduce and let me know. But still, if you delete your local cache, you have to download everything. So that kind of mitigates the problem with downloading all of the metadata, right? If you download all the metadata, well, now you have all the metadata. You only need to get the updates. And Git, we can offload that to Git. That's what it's good at, right? Just how to pull stuff down efficiently, incrementally. Let it do that. If you're not always re-downloading all of the metadata, it might be lower resource requirements on the server. I would be interested to see if that happens, because it is, we know that it is expensive to mirror a large repository. It is expensive to host a large repository. It would be nice if it were not. I think something interesting here that you get for free is you could publish all of your modules in your project all at once in one commit. It's all localized. You just view the commit, see everything that changed in the metadata, as opposed to you publish a few modules and then something happens in your build and it breaks and you don't publish the rest of them, so you have an inconsistent publish. This is mitigated with staging repositories in Maven usually, but that's kind of like an intermediate step that just adds overhead. So I think really the big advantage, another big advantage for me is if you can just make a GitHub repository and that's your repository, I think that's a pretty big win. It's really nice to see how easy it is to create a repository on GitHub compared to how easy it is to make your own Maven repository. If we can reduce that, I think it'll be a really big win for the whole Scala ecosystem. Version controlling your metadata, that also has, I think, quite a bit of benefits. You can have reproducible builds with most of the, more features of your system. If you say dynamic revisions to someone who works with builds, they're going to say, no, don't use them. It's not reproducible builds. And the reason is because there's only ever one version of the metadata on Maven Central. If you publish if you say, I want anything between version 1 and version 2, exclusive, and someone publishes a new version, next time you go back to build that build you built last week, it'll get a different version now. But if you tag, you say, last week I built with this commit from this repository, you can actually improve the metadata over time because you're not going to break people who are relying on your metadata to not change. So I think another useful thing is you can view and audit and diff the metadata changes. So you can say, when you do an update, you say, oh, okay, that now depends on 1.1. Makes it a little bit easier to see the changes in metadata. The artifact repository, I think, is fairly straightforward and is a pretty easy win. If you make the path the hash of the actual content of the jar, and you make it like a cryptographically strong hash, so that in practice there's one hash, one jar. You have the hash, it maps to one jar has one hash. This means that you always know whether you have the right content, right? If there's a path with a certain hash, there's only one content that's going to be at the end of that hash. So if you have that hash in your cache, then it's never going to be any different. And so you don't need to check the remote repository. It's easy to mirror, split, or merge. There's nothing fancy to it. If I mirror something, I don't ever have to contact what I'm mirroring to know whether I'm still up to date, because nothing's going to, right? This hash is always going to correspond to this content. Now they can delete it on that remote repository, but it doesn't matter. It's still valid. The main problem is coming up with a human readable name. I don't really want to see hashes on my class path. It's not going to tell me anything at all. So I think there's ways to get around this, but that's just really the main drawback, I would say. So if we come back to metadata core, this is a very vague proposal on what to do about it, but it kind of identifies the direction, and I'm interested in, well, I'll get to that later, but I'm interested in needs, like what people would have liked to have done, what workflows you have, et cetera. But I think this kind of summarizes what you kind of gives the outline of what you would do with new metadata. And first is identifying attributes. The dependency manager doesn't care whether you have like an organization, a name, whatever. It just says, is the identifier for this the same as this? So if there's some utility in generalizing that to just key value pairs, you just have a map. We can do that. Similarly with version attributes, I've already shown that with cross-versioning. You have like a unique version that uniquely identifies it. So if someone wants to depend on that particular version, they say, I want dependency A with this unique version. It will never ever pick a different version for you. If you just want something that is binary compatible with version 1.0, you say, I want Akka binary version 1.0. Because this is in a structured format, the idea is to make all of this automated for you. It's not supposed to be like, oh, now I have to specify 18 different properties and this is going to be really complicated. The idea is give it a structured format, evolve it as the user's needs, and let's make it happen. So describing attributes, these are just like general. These aren't necessary for dependency resolution. These are the things like main class that I talked about. Maybe you list all the packages in a dependency so that something like Rapture can map packages back to dependencies. So it analyzes your imports And then it can automatically put those dependencies on the class path, so you don't even need to specify those. Generally, I think this is where you have potential for innovation. If you're thinking of something that you would like attached to that metadata, put it here. SBT 013 will put the base URL for your API docs in Maven properties. This is like the super big hack, and anytime I ever hack anything in the Maven metadata, it always comes back to bite me. So I'm not sure what this is particularly going to do. If you can tell me in advance, that would be great. But this is where that would go instead. Make it native, and then when SBT pulls in all your dependencies, it can pull that base URL from all of that metadata and pass it to Scala doc, which as of 2.10.1 will be able to link to external Scala docs. It just needs a mapping from class path entry to base URL. Well, you don't want to provide that for every single one of your dependencies, right? You don't want to go look that up and list them, because well, now you're back to basically explicitly listing your dependencies. So if we can automate that, let's do that, and that's what describing attributes can do. I've already mentioned how artifacts are going to be, would be, put in a repository. You mark them by hash. This is, the nice thing about this is that there's no room for question. It's not going to vary. You say, I want this hash, that's what you're going to get. Then if you sign the metadata, like you sign the commit, you've signed the metadata, you've signed all of the artifacts all at once. Configurations, if you're familiar with Ivy configurations, this would be basically the same thing but cleaned up. I don't really want to go into that. Resolution control is what I was talking about with Akka and their instrumented jars and the basic jars. I want to be able to say this provides this or this conflicts with that. And just as an example, this is, just the table that I threw together, flattened and simplified. You have your standard thing, organization name. You have a unique version, maybe a common version. So someone just says, well, they don't really correspond, but maybe you would say 211.0.0-snapshot, and you would just get the latest one. And of course, this isn't quite like Maven, where it would be like an on-demand fetching. You would have to actually update the metadata through Git. So you would say like git pull, and then right. So then it would get the latest version within that, and you can lock it down. You can lock down that commit, and you don't have to worry about when it will update the snapshot. If you want the snapshot updated, update the metadata. The artifacts listed as hashes. Yeah, it's basically what I've already said. The kind of like absolute biggest problem is compatibility with existing Maven repositories. I don't think anyone would ever underestimate this. I certainly would not. I've seen all of the bugs in Maven. I don't know to what extent you have to reproduce those. I guess part of the solution is you just use Ether and Ivy as your interface. But, and one thing that would be nice would be repository side. So we've said we have this Git repository with metadata in it. So you would just import Maven Central, for example. I mean, I say just import. I have no idea how difficult that is. But that would be the idea, is you do it once, you have a repository that pulls in all the metadata, and you write a conversion tool. So that's a completely separate component. We can develop the rest of it separately. I mean, of course, you have to have a metadata format that is useful and worth converting to. But you do the conversion once, you don't embed it in your tool. Like Ivy has to convert Maven metadata on the fly. And if there's a problem, you have to publish a new version of Ivy, right? And people have to actually start using that, and then SBT has to use that. There's a large delay in between fixing it. But if we have version control and we do batch conversion, you report a problem, we fix it, problem solved, like end of problem. Not 18,000 other people also have this problem. I think the biggest difficulty is probably publishing back to Maven repositories and working with general Maven workflows, things that support Maven. So I think perhaps the best idea that I have now is to proxy this new dependency management repository with like a server that will convert requests for Maven artifacts. I'm not real clear on the details. It sounds like a good idea though. Many of these things are in that category. So there's lots of opportunities though. So if any of these things sound interesting, you should speak up, because it's a good time to get started in the beginning. Really the big thing that I think is most difficult to do is, what do we want to do? What are the workflows that should work well? What are the requirements for dependencies? What things do we need? We can, of course, look at other build systems, other dependency management systems, Linux distribution. We can look at all of these things, but those will only kind of tell us what other people have bothered to solve. There's a lot of smart people, so that may be everything. But anything that's specific to Scala that we run into, this is really where you can help a lot. I don't have all the problems that you have. I have different problems, same with everyone else. But then when it comes to actually doing certain things, there's of course lots of good tasks there. Metadata format and dependency resolution. That's a good like actual computer science, like official hard problem. I think the existing things don't really, they do heuristics. I think there was an attempt to get Maven using sat4j. I don't believe that worked out. A very noble effort, regardless of how it happened. To actually work out. But this is a hard problem. I think it's interesting and worth doing. I think metadata format can really improve our experiences with working, because dependency management is really about collaboration. It's really about me being able to use your binaries, you being able to use mine, and the less time we spend on that, the more time we spend on useful things. Compatibility, writing this tool that imports stuff, that'll be a blast, but I think everyone will respect that. The difference between if you think this is a good idea, the difference between this succeeding and not succeeding is whether it works well with Maven. I mean, that's really the way it's going to work out. The user interface is also important. All of these things are important, but for example, being able to just say, hey, hash this jar, stick it in the cache. You know, nice simple command for that. Simple command for add a repository, do update, stuff like that. I haven't really talked about SBT a huge amount because really a dependency manager should be independent of the build tool. Build tool should be independent. They should inform each other, and certainly I am interested in this working well with SBT and solving SBT problems. But absolutely it should be a separate library with its own user interface and also a good API. But I think those don't need to be together. This is a good example of something that I don't think is a huge amount of work, but is a worthwhile contribution for someone to focus on exclusively. So there's more stuff to do, but there's plenty of things to do. The key here is that if you are waiting for me to do this, it's never going to happen. Maybe not never, but it would take a long time. So the real question though is it worth it? Because it is going to be a lot of effort. Say even I were to do it by myself. That's something that I'm going to be spending time on as opposed to doing something else, fixing your bug in SBT or whatever. Making compilation faster. Oh, that's generally Greg's job now, so maybe I will have time to do this. Again, it's people's interest in doing this is whether it's going to succeed. And yeah, that's about all I have to say other than session tomorrow if this is interesting. So the first question I want to hear from you is it worth it? Because if it's not, let's just go drink. And then if it is worth it, are you interested? What ideas do you have? What is not going to work? Really constructive feedback is the best. You know, what problems have you had now? What can we do? Workflows, reliability, automation are the ideas. So yeah, again, this is just me saying I think this would help. It's certainly not like a guaranteed project. Typesafe's not saying like, yeah, Mark, you should do this. It's kind of like, you know, if it's what we need to do, then let's get people to help, really. All right, well, thank you for your time.